Hey everyone, ready for today's deep dive? We're going to be exploring recurrent neural networks.
RNNs.
Yeah, RNNs. We're going to be focusing on an essay by Jörg-Owe to break down what makes them so special. And let me tell you, these RNNs are like the memory champs of the AI world, right?
Right.
They learn from sequences, whether it's like words in a sentence or notes in a melody. I mean,
Really anything sequential.
anything, stock prices over time, you name it.
Yeah. I think the thing that's so fascinating about RNNs is that they can remember previous information.
Okay.
Which makes them super different from these traditional neural networks that just process data in like a single direction.
Straight line.
One-way street.
Yeah.
But RNNs, they have these loops built in that allow them to retain information from earlier inputs, giving them a kind of memory.
So it's not just looking at each piece of data like in isolation.
Exactly.
It's keeping what came before it in mind.
Exactly.
Almost like a running commentary going on in its head.
Yeah, that's a really good way to put it. Like when you read a sentence, you don't just try to understand each word by itself.
Yeah.
You need the words that came before to give it context, and that's what RNNs are really good at.
Makes sense. But, you know, the essay mentioned that early RNNs, they had this issue, right? Vanishing gradients. What was going on there?
Yeah, the vanishing gradient problem. It's kind of like, imagine you're whispering a message, right?
Okay.
To a long line of people.
Like a game of telephone.
Exactly. And as that message goes down the line, it gets kind of distorted and weaker.
Oh, yeah.
Until by the end, you can barely even recognize it.
Totally.
So in the same way, in those early RNNs, the signal that carries information about like the early parts of the sequence, it would sort of fade out as it traveled through the network.
So it's like the beginning of the sentence is practically forgotten by the time it gets to the end.
Yeah, exactly. And so it made it hard to learn from longer sequences.
Gotcha.
But then these long short-term memory networks came along.
LSTMs.
LSTMs,
Yeah.
exactly. And they were designed to solve this very problem.
Okay, so like how do they fix that?
Well, think of LSTMs like they're RNNs, but they're also equipped with this really sophisticated filing system.
Filing system. Okay, I'm listening. This is interesting.
So they have these special gates, right?
Okay.
That can control the flow of information, deciding, what to keep, what to emphasize, what to discard.
Build like filters.
Yeah, like filters, to make sure those important signals don't just fade away.
Okay.
As the network's processing the sequence.
Makes sense. So LSTMs, they have a much more, I guess, selective memory or maybe a more robust memory than the earlier RNNs.
Yeah, you got it. And there are these two key concepts within LSTMs that often get confused. Cell state and hidden state.
Okay.
Maybe a metaphor would help here.
Ooh, a metaphor. I love good metaphor. Let's hear it.
All right, so imagine a chef.
Okay.
Who has a recipe book and a notepad. The recipe book is the cell state, the long-term memory, the full set of instructions.
Gotcha.
And then the notepad, that's the hidden state. That's like the chef's focus at a particular moment.
Like what's on the counter right now.
Yeah, exactly.
Yeah.
Like what ingredients do I need? What step am I on?
So cell state is the master plan.
Right.
And the hidden state is like the right now of the whole operation.
Yeah.
And both are needed for the dish, or I guess the LSTM's output, to actually come out correctly.
Exactly. Both cell state and hidden state play really crucial roles in how LSTMs process and learn from sequences.
Okay, I'm with you. Now, the essay also mentioned some really cool real-world applications of RNNs.
Oh, yeah.
I mean, the things they can do are pretty mind-blowing.
It really is amazing how they've touched so many different areas of our lives.
Like even just thinking about things like voice assistants.
Yeah.
Or those translation apps we use. It's like, it's RNNs working their magic behind the scenes.
Absolutely. And even beyond language, think about image captioning. RNNs are being used to actually describe what's happening in an image.
Wow.
Making it accessible for everyone, regardless of their visual ability.
That's incredible. So we've got one type of network, but it has all these different applications.
Yeah.
So how do RNNs like stack up against other types of neural networks? Because the essay mentioned that a little bit as well.
Yeah, so there are a few other key players in the neural network world. Like we have feedforward networks, which are kind of like a one-way street.
Okay.
Information flows in one direction, no memory involved.
So great for simple things, but not so much for sequences.
Not ideal for sequences, no. And then we have convolutional neural networks, CNNs.
And those are the image guys, right?
Yeah, those are the image specialists. They excel at finding patterns in visual data.
Okay.
But they don't have that built-in memory like RNNs do. So they can recognize faces, objects, but they wouldn't be as effective in, understanding a sentence.
Right. Or like predicting the next word in a sequence.
Exactly.
So really it's about choosing the right tool for the job, depending on what type of data you're dealing with. If order matters, if sequence matters, you go for RNNs.
Exactly. And for folks who are, interested in getting hands-on with RNNs, there are some really user-friendly tools and frameworks out there.
Oh, that's good to know. Are there any that are particularly good for beginners? I know the essay touched on a couple.
Yeah, like PyTorch, for example, is known for being pretty user-friendly.
Okay.
And it's great for both research and practical applications.
Right.
And there's scikit-learn.
Yeah.
Which is a really good starting point for machine learning in general.
Yeah.
It has some basic RNN capabilities.
So there's plenty out there for people who want to, dive in and explore the world of RNNs firsthand. But I imagine, training these powerful networks, there must be some challenges. The essay kind of hinted at some of the potential pitfalls.
Yeah, there are definitely some challenges. Like training RNNs, it can be tricky. They're known for being, data hungry. They require a lot of data to learn effectively.
Lots of data.
Lots of data. And they also require quite a bit of computational power.
Right. So it's not as simple as just plugging in some data and hitting go. You need the right resources.
Exactly. And even with the best resources, there's the issue of data diversity.
Yeah.
If you train an RNN on a limited data set, you could run into problems, especially when it encounters real-world variations it hasn't seen before.
Right. Like that example in the essay, the RNN was trained on addresses in one format.
Right.
And then it struggled to parse addresses that were from a different region or maybe written in a different style.
Exactly. So it's really important to make sure you're training RNNs on data that's diverse and representative.
So data quality and diversity.
Crucial.
Essential ingredients for robust and reliable RNNs.
Yes.
So we've learned about their structure, how they learn, strengths, limitations. It's a good start to our deep dive, I think.
Yeah, this is fascinating stuff. And, as we go deeper into the world of RNNs, we'll continue to uncover their potential and how they're really shaping the future of AI.
This is great. And thanks to Jörg-Owe for giving us such a great foundation with that essay to really dive into this topic.
Yeah. It's really interesting to think about how RNNs store memory, compared to us humans.
Oh, okay.
We tend to, link memories to events, specific facts.
Right.
But RNNs, they take a more holistic approach.
Holistic, what do you mean by that? Like their memory it's spread throughout the entire network.
Yeah, that's a great way to put it. It's not located in any one spot. It's encoded in the connections, the weights, across the whole network.
So it's more like a feeling or an intuition rather than like a precise specific memory?
Yeah, exactly. It's more about capturing the essence of the sequence.
Okay.
Rather than remembering every single detail.
Like, recognizing a familiar song.
Yeah.
But maybe not remembering all the notes.
Yeah. Exactly. And this distributed nature of their memory, it's actually one of their strengths.
Okay.
Makes them more robust and adaptable.
How so?
Well, think about it. If a human forgets a specific detail, it can really mess up their understanding of an event.
Yeah.
But in an RNN, if a single connection or weight is adjusted slightly, it might not have a huge impact on the overall performance.
So it's like built-in redundancy.
Exactly.
Different parts of the network can kind of step in and compensate for each other.
Exactly. So they're less susceptible to noise or errors in the data.
Makes sense.
They can still kind of grasp those general patterns, even if some of the specifics are missing.
That's pretty cool. It's like a different way of remembering than we're used to as humans.
It is.
Yeah.
And that difference, it actually highlights one of the key challenges in understanding how RNNs work.
Oh, how so?
Well, because their memory is so spread out, right?
Yeah.
And encoded in these complex patterns, it can be tough to pinpoint exactly how they arrive at their conclusions.
So it's kind of like a black box, in a way.
A bit of a black box, yeah.
We know what goes in, we know what comes out.
Yeah.
But the exact process is a little bit hidden.
It's a bit mysterious. And this lack of transparency, it can be a barrier to wider adoption, especially in fields where explainability is really important.
I can see that, yeah. Like, in healthcare.
Healthcare.
Finance.
Absolutely.
You want to understand why an AI is making the decisions it's making.
Yeah, you want to be able to trace the logic. But with this distributed memory and the complex inner workings, it's difficult to get that level of transparency.
Sounds like there's still a lot to uncover about the inner workings of these RNNs.
There is. But the research is ongoing, and with time, hopefully we'll gain a deeper understanding of how these things tick. Now, moving on a bit, let's talk about some of the variations and extensions that have been developed based on the basic RNN architecture.
Oh, cool.
Like, the essay mentioned something called bidirectional RNNs.
Bidirectional.
The RNNs. So unlike these standard RNNs, which only process information in one direction.
BRNNs process it in both directions.
Oh, wow.
Forward and backward.
So like reading a sentence from left to right and then right to left again.
That's a good analogy. So this allows them to consider the context of each element from both the past and the future within the sequence.
Oh, I see. So you're getting two perspectives on the same data.
Yeah.
Which should lead to a better understanding, I guess.
A richer representation. How they actually do it is they have two separate hidden layers.
Okay.
One processes the sequence forward.
Okay.
The other processes it backward. And then at each step, they combine information from both layers.
So they're getting a double dose of context at every point.
Exactly. And this bidirectional processing allows them to pick up on dependencies, relationships that might be missed by those regular unidirectional RNNs.
Makes sense.
They've been really successful in things like natural language processing, speech recognition.
Where context really matters.
Exactly.
Yeah.
Now, the essay also mentioned another really interesting extension.
Attention mechanism.
Attention mechanisms.
Yeah. So instead of treating all parts of the input sequence equally, attention mechanisms allow RNNs to focus on specific parts that are most relevant to the task at hand.
So it's like skimming through a long article and picking out the key sentences and paragraphs instead of reading every single word.
That's a great way to think about it. So they assign a weight to each element, right, in the sequence, indicating how important it is. And these weights are learned during training, so the network can actually adjust its focus based on the data and what it's trying to do.
So they're learning to prioritize what's important.
Exactly. Exactly. And this selective attention, it makes it possible for RNNs to handle much longer, more complex sequences.
Yeah, because they're not overwhelmed by trying to process everything equally.
Exactly. It's like having a spotlight that highlights the most important information.
It's a pretty clever mechanism. It seems like attention mechanisms have had a big impact on AI in general, right?
They have, especially in natural language processing. They've led to big improvements in machine translation, text summarization.
It's amazing how, these innovations keep pushing the boundaries of what RNNs can do.
It really is. And as the research in this area progresses, I think we can expect to see even more creative and powerful extensions and variations popping up. It's a really exciting field.
I'm going to get a sense of just how powerful and versatile these RNNs really are.
They are. But like any powerful tool, it's important to be mindful of their capabilities and limitations as we continue to, develop and apply them. We've covered a lot of ground in this episode, looking at the inner workings of RNNs, some of the exciting advancements.
Yeah, it's been a great deep dive so far. And again, thanks to that essay by Jörg-Owe for setting us off on this journey into the world of RNNs. One of the things that really struck me in Schneppat's essay was just how many different applications there are for RNNs.
Yeah.
It's amazing.
I think it really speaks to their adaptability.
Well,
that ability to process sequences makes them suitable for problems that, on the surface, seem completely unrelated.
It's like they're the Swiss Army knife of AI tools.
Right. Yeah.
From understanding language to analyzing financial markets.
Yeah.
It seems like the possibilities are endless.
Yeah. Like take speech recognition, for example.
Okay.
The way we speak is inherently sequential, right?
Yeah.
Words follow words. Sounds build upon one another. RNNs are just a natural fit for capturing that flow.
It's not just recognizing individual words, though, is it? It's understanding the context of the whole sentence, the whole conversation even. That's what makes human communication so nuanced.
Exactly. And they're able to use that information, what's been said previously, to form a more accurate interpretation.
It's like they're learning to listen like humans do.
Yeah.
Picking up on the subtleties of a conversation.
Yeah.
Pretty incredible. And what about machine translation? I mean, it almost seems magical that you can feed text in one language into an RNN and it can output a decent translation in another language.
It really comes down to how they learn to map the relationships between words and phrases across different languages.
Okay.
It's not just a simple word-for-word substitution. It's about capturing the underlying meaning, the nuances.
So they're not just acting as dictionaries, they're kind of learning the essence of language itself.
Right. They're identifying the patterns in how ideas are expressed in different languages.
That's remarkable. And then there are the applications that go beyond language completely, Like the essay mentioned, time series analysis, things like predicting stock prices.
Yeah, that's a great example of how the concept of a sequence can extend beyond just words. The price of a stock today is influenced by its price yesterday, last week, even further back.
Okay.
RNNs are really good at modeling those dependencies over time.
So they're able to see the story the data is telling,
Yeah,
the trends and fluctuations that might hint at what might happen in the future.
exactly. And that's valuable not just in finance, but in any field that deals with data that changes over time.
Yeah.
Weather patterns, climate change, even predicting equipment failures to avoid those costly downtimes. It's about finding the patterns in the sequences.
Really is incredible how versatile this one type of network can be. Are there any areas where RNNs might not be the best tool for the job?
Well, there are certainly situations where other approaches might be more suitable.
Oh.
Like, for example, if you're dealing with extremely long sequences,
Mm-hmm.
the limitations of their memory can start to become a problem. There are some newer architectures like transformers, which are much better equipped to handle those long-range dependencies.
So it's all about picking the right tool for the task, right?
Exactly.
RNNs are great for a lot of sequence-based problems, but there may be other tools that are better suited for specific challenges.
And it's important to remember that AI is constantly evolving.
Right.
New architectures, techniques are being developed all the time, so you gotta stay informed and keep exploring.
It sounds like our deep dive into RNNs has given us a pretty good overview. We've covered the architecture, strengths, limitations, how they're being used.
And it all started with that fascinating essay by Jörg-Owe.
Yeah, it's really amazing how a single piece of writing can spark such a wide-ranging exploration.
It really is.
It just goes to show the power of ideas, the importance of keeping on learning,
Absolutely.
delving into those topics that grab our attention.
And for our listeners out there, armed with this newfound knowledge of RNNs, I have a challenge for you.
Okay, a challenge. I like it. What is it?
Go out and look for the sequences in the world around you, the patterns in nature, the rhythms of music, the flow of conversation. Start seeing the world through the lens of RNNs.
See the interconnectedness of things, the hidden threads that tie everything together.
Exactly. And who knows, maybe you'll even be inspired to create something new with this knowledge. The possibilities really are boundless.
Well, on that note, we'll leave you to continue your own explorations. Until next time, keep diving deep.